A self-driving car approaches an unavoidable collision. In a split second, its algorithms must decide: swerve left and strike an elderly pedestrian, or swerve right and hit a group of schoolchildren. This isn't just a thought experiment anymore. It's a real ethical dilemma that engineers and ethicists must grapple with as artificial intelligence becomes increasingly integrated into our daily lives. The rapid advancement of AI technology has brought us to a critical juncture where philosophical questions that have challenged humanity for millennia must now be translated into explicit code. Our previous exploration of AI's geopolitical implications revealed how this technology is reshaping global power dynamics. Today, we confront an even more fundamental challenge: ensuring that AI systems align with human values and ethical principles. This challenge extends far beyond the dramatic scenarios of autonomous vehicles. Every day, AI systems make countless decisions that affect human lives, from determining who gets approved for a loan to suggesting medical treatments, from screening job applications to predicting criminal recidivism. Each of these applications raises profound ethical questions about fairness, transparency, accountability, and human dignity. The ethical landscape of AI. The ethical challenges posed by AI can be understood through several fundamental lenses, each revealing different aspects of the complex relationship between artificial intelligence and human values. Consider first the question of moral agency in AI systems. Traditional ethical frameworks assume human decision-makers capable of moral reasoning and empathy. But AI systems operate through pattern recognition and statistical inference, raising fundamental questions about their capacity for genuine ethical deliberation. When an AI system makes a decision that affects human lives, who bears moral responsibility for that decision? The system itself, its developers, or the organizations deploying it? This question becomes particularly acute in contexts where AI systems must make life or death decisions. Autonomous weapons systems represent perhaps the starkest example. Should machines be allowed to make independent decisions about the use of lethal force? The debate extends beyond military applications to medical AI systems that influence treatment decisions, or financial algorithms that can affect economic survival. Privacy and surveillance present another fundamental ethical challenge. AI systems thrive on data, often personal data that reveals intimate details of human lives. The ability of AI to process and analyze vast amounts of information creates unprecedented capabilities for surveillance and control. Facial recognition systems deployed in public spaces, sentiment analysis of social media posts, and behavioral prediction algorithms all raise profound questions about privacy, consent, and human autonomy. The relationship between AI and human labor forces us to confront questions of economic justice and human dignity. As AI systems become more capable of performing both routine and complex tasks, we must grapple with the ethical implications of technological unemployment. Beyond the economic impact, there are deeper questions about the role of work in human life and the potential psychological and social effects of widespread automation. The challenge of algorithmic bias. Perhaps no ethical challenge in AI is more pressing than the problem of algorithmic bias. AI systems learn from historical data, and when that data reflects societal biases and discrimination, AI can amplify and perpetuate these injustices at scale. Consider the case of Compass, an algorithm used in the US criminal justice system to predict recidivism risk. Studies have shown that the system exhibits significant racial bias, consistently overestimating the risk of recidivism for black defendants while underestimating it for white defendants. This isn't an isolated incident. Similar biases have been documented in AI systems used for hiring, lending, healthcare, and other critical applications. The sources of algorithmic bias are multiple and interrelated. Training data bias. AI systems learn from historical data that often reflects societal prejudices and structural inequalities. For example, if historical hiring data shows a preference for male candidates in leadership positions, an AI system trained on this data may perpetuate this bias. Sampling bias. When the data used to train AI systems doesn't accurately represent all populations, the resulting algorithms can perform poorly for underrepresented groups. This has been particularly evident in healthcare AI, where systems trained primarily on data from certain demographic groups may provide less accurate diagnoses for others. Measurement bias. The choice of what to measure and how to measure it can introduce systematic biases. For instance, using postal codes as a proxy for creditworthiness can encode racial and economic segregation into lending algorithms. Aggregation bias. When AI systems treat disparate groups as homogeneous, they may fail to capture important differences between subgroups, leading to poor performance for specific populations. Transparency and explainability. The foundation of trust. The complexity of modern AI systems creates a fundamental challenge for accountability and trust. Many contemporary AI systems, particularly deep learning models, operate as black boxes. Their decision-making processes are often opaque even to their creators. This lack of transparency raises several ethical concerns. Accountability. How can we hold AI systems and their creators accountable for decisions when we can't understand how those decisions were made? Due process. In contexts like criminal justice or lending, individuals have a right to understand and challenge decisions that affect them. How can this right be preserved when decisions are made by opaque AI systems? Error detection. Without understanding how AI systems reach their conclusions, it becomes difficult to identify and correct errors or biases in their operation. The field of explainable AI, XAI, has emerged in response to these challenges, developing techniques to make AI decision-making more transparent and interpretable. These approaches include local explanations, methods that explain individual decisions by identifying which features were most important for that specific case. Global interpretability, techniques that provide insight into the overall behavior and decision-making patterns of AI systems. Counterfactual explanations, approaches that show how different inputs would have led to different outcomes, helping users understand what factors influence the system's decisions. Building ethical AI systems. Principles and frameworks addressing the ethical challenges of AI requires a comprehensive framework that combines philosophical principles with practical guidelines for development and deployment. Several key principles have emerged as fundamental to ethical AI. Beneficence. AI systems should be designed and deployed to benefit humanity. This requires careful consideration of both intended and unintended consequences of AI applications. Non-maleficence. AI development should actively avoid causing harm. This includes not only direct harm but also indirect harm through bias, discrimination, or privacy violations. Autonomy. AI systems should respect human agency and decision-making capacity. This principle requires careful consideration of when and how AI should augment or replace human decision-making. Justice. The benefits and burdens of AI systems should be distributed fairly across society. This includes ensuring equal access to AI benefits and protecting vulnerable populations from potential harms. Transparency. AI systems should be as transparent as possible about their capabilities, limitations, and decision-making processes. These principles must be translated into practical guidelines for AI development and deployment. Design phase. Diverse development teams to bring multiple perspectives, careful consideration of training data selection and curation, integration of fairness metrics into model development, regular testing for bias and discrimination. Deployment phase. Clear communication about AI system capabilities and limitations, regular monitoring and auditing for unexpected behaviors or biases, mechanisms for human oversight and intervention, clear processes for addressing complaints and concerns, ongoing assessment. Regular evaluation of social impact, updates and modifications based on real-world performance, continuous stakeholder engagement and feedback, regular ethical reviews and assessments. Practical steps toward ethical AI. Moving from principles to practice requires concrete steps at multiple levels. Organizational level. Establishing ethics boards and review processes, developing clear guidelines for AI development and deployment, investing in diversity and inclusion in AI teams, regular training on ethical considerations in AI. Technical level. Implementing fairness metrics in model development. Developing and using explainability tools, regular testing for bias and discrimination, building privacy protection into system design. Societal level. Developing industry standards for ethical AI, creating mechanisms for stakeholder input and oversight, supporting research into ethical AI development, fostering public dialogue about AI ethics. The path forward. As we look ahead to our next discussion on AI regulation, we must remember that ethical considerations should guide both technical development and policy frameworks. The challenges we face in ensuring ethical AI are substantial, but they are not insurmountable. Success requires a commitment to several key principles. Proactive engagement. We must address ethical concerns during the design and development phase, not as an afterthought. Continuous learning. As AI technology evolves, our understanding of its ethical implications must also evolve. Inclusive dialogue. Ethical frameworks for AI must be developed through broad consultation with diverse stakeholders. Practical implementation. Ethical principles must be translated into concrete practices and measurable outcomes. The future of AI will be determined not just by technical capabilities but by our ability to ensure that these powerful tools serve human values and promote human flourishing. By building ethical considerations into the foundation of AI development, we can work toward a future where artificial intelligence enhances rather than diminishes human dignity and well-being.